Hi everybody. This is a screencast about connected body problems, which is an application of Newton's third law that will count as an extra credit. So I've got a homework assignment that's just like the problem I'm about to show you. And then when you finish the homework assignment, you'll need to be able to take a quiz on the topic. Then you'll get some extra credit. It's not a bad topic, but it's just one that I think computationally might take a little bit too much time for the whole class. So here's the problem. A 10 kilogram box is pushed into an 8 kilogram box with a force of 40 newtons. If they then move across a frictionless table, find their acceleration and the force between the boxes. The boxes are on a horizontal surface. So first we draw a picture. And we've got a horizontal surface like so. We've got a 10 kilogram box, which is in front. So there's the 10 kilogram box, 10 kg, so you remember. And that's pushed into an 8 kilogram box. And the 8 kilogram box we'll put there. We'll label it 8 kilogram. And there's going to be one force acting on the system, and that's this pushing force, which has a value of 40 newtons. So we'll indicate that as 40 newtons. Good. All right. So there's the diagram. And the trick to this kind of problem is to see it in two ways. First way is to see it as a whole system. So if you consider the whole system, then you've got a 40 Newton force acting on an 18 kilogram mass. So you don't consider the force in between the two objects. You just consider F equals ma. Now that's the net force equals ma, but in this case there's only one force. And the combined mass is 18 kilograms, so you get 40 equals 18a. And so the acceleration is 40 over 18. Here's the calculator, which is 2.22 meters per second squared. Okay, so that's the whole system. But then you need to consider what's happening to an individual object. And so what you then realize is that there's got to be, because of Newton's third law, there's got to be equal and opposite forces acting in here. Sorry if this is drawn blue on blue. But you've got one force of the 10 kilogram object on the 8 kilogram object, and you've got another force that's the 8 kilogram object on the 10 kilogram object. And they should be equal and opposite. So the next step is to only consider the 8 kilogram object. Now on the 8 kilogram box, there's only one force. But we don't know what that is. It's not the same. It's not the same as the 40 Newton force, because the 40 Newton force is acting on the whole thing together. On the 8 kilogram box, if we do F equals ma, it's only the force that's acting between the boxes, and that's only on the 8 kilogram mass. So it's F equals 8 kilograms times the acceleration, which we know is 2.22 repeating. So we can bring that back in and multiply it by 8, and we get 17.8. So that equals 17.8 newtons. And that's the whole problem. But if, on the other hand, we only want to consider the 10 kilogram box, now this is not something that you have to do, but it does make things a little bit, well, it'll make it clear that it's the same thing. So if you want to just look at the 10 kilogram box, there you've got two forces acting. You've got the 40 Newton force, so when you do F equals ma, you've got the 40 Newton force, which is 40, minus this force right here, this force that's, this force that's pushing from the 8 kilogram into the 10. So it's 40 minus F equals ma, but there the mass is 10. The acceleration is still 2.22. And you get F equals, if we rearrange a little bit, F equals 40 minus 22.22 repeating. which again is 17.8 newtons. Needs to be the same. These two forces need to be equal and opposite. Now when you do the pulley system, it's going to be the same idea. But when you have a pulley system, this is for some of the other problems that you've got. When you have a pulley system, you're going to have your pulley here, and you're going to have your masses hanging from it, like this. And the masses are going to be different. So you'll have one mass there. You'll have another mass maybe there. And they'll be sliding down past each other, so one will be falling. Maybe it's better if I draw it down here so you can see it better. There. So they'll have different masses. So there's going to be a force of gravity and a tension force, but the trick is the tension force is going to be the same. And I'll leave you to try to figure that out. Let me know if you have any problems on it. But it's the same idea, except you've got a weight pulling down here, and then another weight pulling down in the opposite way there. So first you consider the whole system, then you consider just one force or just the other force. And it doesn't matter which one you consider. I hope this works out.